Hello, in this video we are going to go over chi-squared. It is a statistical analysis to basically determine whether something that we observe in real life is what we expect, and this is going to be in the context of Punnett squares and genetics. So in a previous video we learned about how to use a Punnett square to basically determine what we expect to see in these offspring if we were to mate two organisms together, and the types of phenotypes that we would see in the offspring. And so in the chi-squared analysis, we are basically going to be using math to determine whether what we see in real life represents what we expect in a Punnett square. So as I already mentioned, Punnett squares provide what we consider our expected results. So I'm just going to make up a story here to give some context. So let's do a Punnett square of, capital A, lowercase a for, let's say, dogs and fur color. And so let's say that capital A is black fur, which is dominant, and lowercase a is brown fur, which is recessive. So when we look at the offspring, which are in the boxes in the middle, our expected results are going to be that 3/4 of the offspring are going to have black fur. And that is because the capital A, that is dominant, homozygous dominant, that is going to have black fur. And then our two heterozygous are also going to have black fur. And then the last organism or last box here is representing 1/4, which will have brown fur. Now, remember, it doesn't really necessarily mean you have to have 4 children or 4 offspring, but we're just looking at the ratios. So 75% are going to be black fur, and 25 we're going to expect to have brown fur. And so those are the expected results from the Punnett square. Now, let's say we actually do this in real life. So we get 2 dogs that are capital A, lowercase a, and we, breed them so that they produce offspring. Now, let's say that the offspring, you get 20 puppies, which is a lot, but, I'm just making up a story here. So with 20 offspring, let's say 14 of them have black fur. Now, our expectation would have been that 15 had gotten black fur, because remember that it should be 3/4, and 3/4 of 20 is 15. So we expected 15 to have black fur, but we actually got 14. Remember that real life is never going to be exact. So yeah. Now, for the brown fur, we had expected 5 of them. We only expected 1/4 of the offspring to have brown fur, but we actually got 6, so 1 higher. And so those are your expected results, again, using the Punnett square, and then this is what we actually got in real life. Now, it's not super far off, but it is different. And so the question is this statistically significant? And we use chi-squared to do this. So this is the chi-squared equation. It determines whether our real results are statistically different from our expected results. And what will happen is if your real result is very different from your expected, statistically speaking, you will get a very high value for the chi-squared equation. And so let's break down this equation. So chi-squared equals the sum of your observed minus expected over expected squared for the top part. And then you're going to repeat this for how many observations you have. So we had 14 for black fur and 6 for brown fur, so we're going to do this twice. So basically, this is how you would set it up. So the chi-squared equals, and we would start with the first observation, which is the black fur, and we have 14, which is our observed, minus 15, which is our expected squared, divided by 15. Remember, you want to do the parentheses first, then square, then divide. And so when you do that, you get 0.0667, and then you would repeat that for the brown fur. So we observed 6 brown fur, even though we expected 5. Square that, and then divide by 5 to get 0.2. And then when you add those two together, you would get 0.2667. And again, this is a very simple chi-squared where we only have 2 expected results. If we were looking at multiple phenotypes, you would obviously have more things to add. The chi-squared equation gets longer and longer as you have more phenotypes that you're looking at. but to keep things simple, we're just looking at two different phenotypes, and so we get 0.2667 as our chi-squared value. Okay, and so you just leave it like that. Now, what does this mean? Well, then there's a table, and so the chi-squared table basically gives us a cutoff value to determine if it's significant or not. First thing you want to do is determine your degrees of freedom. So there's different ways to determine the degrees of freedom, but to keep it simple in biology for Punnett squares specifically, the equation is your number of phenotypes that you're dealing with minus 1. And so for us, it's 2, right? We have black fur and brown fur. That's 2 phenotypes minus 1. So our degrees of freedom is just 1. So the lowest number possible. And in biology, as a standard, we use 0.05 as our p-value. Different fields or different, requirements might do a p-value of 0.01 or whatever, but just for the purpose of this video, we're going to use the 0.05 p-value. So you're basically going to find your degrees of freedom, which is 1, and your p-value, which is 0.05, and our golden number right here is 3.84. And basically what you're going to do is determine the value that you calculated, is it higher or lower than this? If it is higher, then that means that what you observed in real life is statistically different from what we expected using the Punnett square. So for our chi-squared, it was 0.2667, which is actually less than 3.84. So our result is not statistically significant, meaning that what we got of 14 black fur and 6 brown fur puppies is essentially the same, or is what we expect from a Punnett square. Obviously, it's not exact, right? We expected 15 and 5, and we actually got 14 and 6, but what chi-squared is saying is it's close enough. And so there's nothing weird going on in terms of the genetics. The fur color is not, sometimes your fur color might be, on the X chromosome, and so then we would have different statistics going on, right? So that's kind of what chi-squared does, is it tells you, is what you're observing following normal genetics, or is there something else going on? And if your chi-squared value is really high and it is statistically significant, statistically different, then that means that it is not following the normal genetics that we see in a Punnett square, and there's something else happening. So something that, is affecting it in a different way. And so that's it. And so in our specific case, there is nothing, funky going on. We just got the normal result. But, in other cases, you might get a different result, and you would have to explain that by figuring out what's going on genetically. Thanks for watching, and I will see you in the next video.